Hello, my name is Marcelina Lirius and welcome to Math Monday. Our lesson for today is describing the effects of parameter changes or transformations on the graph of parent functions. Before we start, please be ready with your supplies. You will need your pen, your notebook, and get ready with your devices also, as we will be using the Desmos graphing calculator to graph functions. So let's start with linear functions. So we will consider the linear function y is equal to mx plus b, where b is 0 here, and our parent function when m is equal to 1. So the equation y is equal to x is our reference graph. We will call this as our parent function. The value of m is 1, and that is the coefficient of x. And we are going to compare this to the equation y equals 4x and the corresponding graph. In this case, our m, or the slope m, which is the coefficient of x, is equal to 4. And also, when y is equal to negative 2x, when m is equal to negative 2. So if we have the parent function y is equal to x, okay, y is equal to x. So we have this blue line here. It passes through the origin. And when your x is 0, y is 0. When x is 2, y is also equal to 2. So that explains the equation here that describes the equation y is equal to x. X is 4, y is 4. That's the point here. Now, compare this to the graph of y is equal to 4x. This red line represents the graph of y is equal to 4x. So what happens to the graph when we increase the value of m, or the slope m, from 1 to 4? Okay, write down your answer on your notebook, or let's see how your answer compares to mine. Okay, so if we have y is equal to x, notice that the line here, y is equal to x, compared to the line y is equal to 4x in terms of steepness, okay? Y is equal to x is flatter compared to y equals 4x. So as you increase the value of the slope m, the line becomes steeper and approaches the y-axis. It approaches this y-axis. Okay, it becomes steeper. And if we compare these two graphs, both of them have positive slopes. We compare this to the line whose slope is negative. Okay, so the first two lines, notice that as x increases, y is also increasing also. So this is the case when the line is rising. Okay, this is inclined to the right. Same here, when x, as the value of x increases, y also increases. But this is not the same case when we have a negative slope. Okay, in this green line, which represents the equation y equals negative 2x, the line is inclined to the left. Okay, so if you have a line whose slope is negative, the line is falling. Okay, falling because as your x increases, notice that as we move from left to right, the value of y decreases. Again, if we compare this to graphs 1 and 2, these two lines here, these two lines are rising. And the line with a negative slope, the line is falling. Okay, I'll give you time to process. You can take down notes. Then let's move on by graphing all these three lines in one coordinate plane. So going back, this blue line in the earlier slide, in the previous slide, is y equals x. Then the red line, y is equal to 4x. Notice the effect. When we changed the value of m equals 1 to m equals 4, this line here moves closer actually to the y-axis. So as we increase the value of m, the line becomes steeper, okay? And both these two lines have positive slopes and they're both rising. They're both inclined to the right. And the green line, which we showed earlier, this is the line y equals negative 2x. It has a negative slope and this line is falling. Okay, it's falling as your x increases, y decreases. So to summarize, the effect of changing the value of m on the graph of a linear function, the effect is on the steepness of the line. Okay, so from rising, as you increase it from 1 to 4, then when the slope of the line changes from positive to negative, the line, okay, changes from rising to falling. How about if we change another parameter, which is the y-intercept? So in the equation y equals mx plus b, following examples, we will be changing the value of b. And let's see what will be the effect of this change in the graphs of the functions. Okay. So we start with our parent function. Our parent function y is equal to x. Okay, notice that for all these three examples, okay, our m are the same. M is 1, the slope is 1, 1, and 1. The coefficients of x represent the slope. So all this, notice that the inclination, they're the same, okay? However, we are changing the value of b, or the y-intercept. So in this case, we have, okay, let's see. I have here plus 0. It's understood to be plus 0. And, okay, plus 0 here, plus 3, and minus 1. So we change this value of b, or the y-intercept, from our parent function y is equal to x. Okay. So this first line is the line representing y is equal to x. This is the same as the original parent function we had in example 1. Next, if we move, or if we change the value of b from 1 to 3, so in the blue line, when x is equal to 0 and y is 0, notice that this point on the y-axis has been moved 1, 2, 3 units up. Any point, okay, here is moved 3 units up from the blue line to the red line. So the plus 3 here represents the movement of the graph of y is equal to x 3 units up. 3 units up. And in the third line, okay, which is the line y is equal to x minus 1, where the y-intercept is negative 1. So the effect of changing this parameter is a movement of the parent function here, okay? This point here, or any point on the blue line, will be moved 1 unit down. So notice it's moved 1 unit down. So for any change in the value of b, it corresponds to a displacement. So if it's positive, the graph will move up. And if it's negative, the parent function will move down. Okay, process the information. You can take down notes. And if we graph all the three lines in one coordinate plane, again, our blue line is the line y is equal to x. The green line is y equals x minus 1. And the red line is y is equal to x plus 3. So this is the beauty when you put all this on one coordinate plane so you can see the movement of the parent function. So notice that we have y equals x, okay? Y equals x. So y equals x. Then the red line is y equals x plus 3. Even just looking at the equation, notice that there is a plus 3. So we expect the line to be moved 3 units up. So from this point here on this blue line, 0, we move 1, 2, 3 units. Any point on the blue line, if we consider this point here, we move 3 units up. 1, 2, 3. You will land on this point. So take another point down here on this blue line. Let's see, 1, 2, 3. So any point on the blue line will be moved 3 units up. In the same manner, when you have y equals x minus 1, any point on the parent function y is equal to x will be moved 1 unit down. That is your y equals x minus 1. See the transformation from y equals x to y equals x minus 1. That means move each point on the blue line 1 unit downwards. So 1 unit down, 1 unit down. This blue line moves 1 unit down on the green line. Okay, you can write down the summary in your own words. What happens when we change the value of the y-intercept? How will the graph compare to the original or to the parent function? Okay, so the effect again is the movement, the displacement of the graph upwards or downwards. So in our next lesson, we'll discuss the effect of changing the parameters on quadratic functions. So I want you to do some practice ahead. Google Desmos graphing calculator, and on the equation bar, type these 3 functions and see how the graphs compare or how they differ from the parent function. What is the effect when we change the value of a here, which is 1 to 1/3, then to 3? So that concludes our session for today, and I hope to see you next week.